Hello students, welcome to the lecture on project scheduling and dynamic programming, and after this lecture we will be able to learn the following objectives. Explain the basic concepts of project scheduling, understand the CPM and PERT, describe the concept of float and its relation with critical path, understand resource allocation and leveling. Explain basic concepts of PERT, cost systems. Let us start with the introduction of project scheduling and dynamic programming. Network analysis is a technique related to sequencing problems which are concerned with minimizing some measure or performance of the system, such as the total completion time of the project, the overall cost, and so on. The technique is useful for describing the elements in a complex situation for the purpose of designing, planning, coordinating, controlling, and making decisions. Network analysis is specially suited to projects which are not routine or repetitive and which will be conducted only once or a few times. Two most popular forms of this technique now used in many scheduling situations are the critical path method and the programmed evaluation and review technique, popularly known as PERT. This method differentiates between planning and scheduling. Planning refers to the determination of activities that must be accomplished and the order in which such activities should be performed to achieve the objective of the project. Scheduling refers to the introduction of time into the plan, thereby creating a timetable for the various activities to be performed. CPM uses two time and two cost estimates for each activity, one time cost estimate for the normal situation and the other estimate for the crash situation, but does not incorporate any statistical analysis in determining such time estimates. Now we will discuss about some basic concepts. To understand these techniques, one should be familiar with a few basic concepts of the network analysis, of which both CPM and PERT are special applications. A network is a series of related activities which result in some product or services which in turn contributes to the goals of a business or industrial or similar other organization. Two terms in context of network analysis are very important: activity and event. An activity represents some action, as such is a time-consuming effort necessary to complete a particular part of the overall project. Thus, each and every activity has point of time where it begins and a point where it ends. Event represents the start or completion of some activity and as such consumes no time. Hence, an event is a specific instant of time that denotes the beginning and end of an activity. An event cannot accomplish until all activities preceding it have been completed. Therefore, an event is a milestone or signal for dependent succeeding activities to begin. Network diagram is a pictorial presentation of the various events and activities concerning a project. In this, each event is represented by a circle and arrows are used to indicate activities. In a complete network, there must always be one network beginning or the starting event and one network ending event. In the figure, each arrow represents an activity and each circle an event. Circle 1 represents the starting event and circle 7 represents the ending event. The names of the activities are generally stated just above the corresponding arrows. Thus, A in the above diagram is the same of the activity represented by the arrow just drawn below it. It may also be pointed out here that it is not necessary for an event to be the ending event of only one activity, but an event can be the ending event of two or more activities, in which case the said event is technically described as node. Similarly, if the event happens to be the beginning event of two or more activities, it is technically called as the burst. The activities in the diagram can be classified as preceding activities, succeeding activities and the concurrent activities. Activities which must be accomplished before a given event can occur are termed as preceding activities. Activities which cannot be accomplished until an event has occurred are termed as succeeding activities, and activities which can be accomplished concurrently are known as concurrent activities. This classification is relative, which means that one activity can be proceeding to a certain event and the same activity can be succeeding to some other event, or it may be a concurrent activity with one or more of the activities. We require the following information for each activity in the project. For the preparation of the network diagram, the sequencing requirements for an activity must be known, that is, the set of activities which must be completed prior to the beginning of each specific activity should be known. An estimate of the time each activity will take should also be known. Here, we will discuss about critical path method, CPM. Critical path method is a graphical technique for planning and scheduling of projects. This technique involves the preparation of the network in the form of arrow diagram and its analysis to indicate the wheel path. It has the potential for scheduling of a task in minimum time and of cost in accordance with specified constraints. After preparing the network diagram and indicating the times for each activity as stated above, we can now mention the various possible paths for determining the critical path under the CPM. The critical path, being the longest path, can easily be found out from the possible paths as the one taking the maximum time in the completion of the project. Network diagrams are in 4 parts. The critical path is important as its length determines the minimum time required for the completion of the project. The critical path requires greater attention because of the following reasons. The critical path highlights those activities which must be performed more rapidly if the total project completion time is to be reduced. Any delays in activities which are on the critical path will produce delays in completion of the project, that is, will postpone the final completion date of the project. Advanced planning and improvement along the critical path may cause another path to become critical. The computations or critical path are the earliest start time and the earliest finish time for each activity can be obtained as under. Set the EST of the first activity equal to 0. Then add the estimated time to perform the first activity to its EST and the results the EFT. For the first activity, now take any activity for which all its immediate preceding activities have EST and EFT. The EST of such an activity is equal to the largest of the EFT values of its immediate preceding activities. If we proceed this way, that is, from left to right, finding the EST and EFT of all activities in the network, we are said to adopt what is known as the forward pass. We will have to work out the latest start time or LST and the latest finish time or LFT for each activity to be performed. In the completion of the project, this can be done as under start at the end of the network diagram and first set the LFT for the last activity equal to EFT for that activity. Then subtract the estimated time to perform the last activity from its LFT. To obtain its LST, now take any activity for which all of its immediate succeeding activities have LST and LFT values. The LFT of such an activity is equal to the smallest of the LST values of its immediate succeeding activities. If we proceed this way, that is, from right to left, finding the LST and LFT of all activities in the network, we are said to adopt what is known as the backward pass. We can now list down EST and EFT values as per the forward pass and LST and LFT values as per the backward pass for each activity and also the latest event LT and earliest event ET of all events concerning in the following form. Network analysis is a technique related to sequencing problems which are concerned with minimizing some measure performance of the system. The concept of float and its relation with critical path. The float for each activity can be calculated by taking the difference either between the LST and the EST or between LFT and EFT for that activity. Float will always be 0 for those activities which are on the critical path. This is as per the definition of critical path, since any delay in a critical activity will cause delay in the completion of the project. The table indicates the total free and independent floats of each activity concerning illustration. The above table makes it clear that activities C, F and I have 0 float, since these are the activities on the critical path. Activities A, B, D, E, G and H have float of 9, 1, 9, 6, 6, 1 week respectively, which means that they may be delayed up to their float time beyond their EST without having any effect on the duration of the total project. Float, whether positive or negative, is generally considered as undesirable and should be avoided to the extent possible. Positive float simply means that there is idle time and resources with corresponding implicit costs burden. When the time to be allowed for the completion of the project is less than the time which is required as per the critical path analysis for the completion of the project, float happens to be negative, which simply represents that project requires more resources than are normally available. Resource allocation and leveling. Resource allocation implies the task of allocation of resources to various activities in such a manner that the allocation is considered as acceptable under the given situation. The task of allocation of resources is of vital importance, as the final schedule depends upon the quantity of deployment of resources. This depends upon several factors like availability of resources, requirements, restrictions in regard to completion date, etc. Various types of problems may be encountered in this connection, but we shall consider only 2 of such problems. Resource leveling. Limited resource allocation. Limitations of CPM. CPM operates on the assumption that there is a precise known time that each activity in the project will take, but this may not be a true assumption in real life. CPM does not incorporate statistical analysis in determining time estimates. It is difficult to use CPM as controlling device for the simple reason that one must repeat the entire evaluation of the project each time changes are introduced into the network. It may be remembered that CPM was initially developed as a static planning model and not as a dynamic controlling device. Let's describe the program evaluation and review technique. PERT is termed as the approach of multiple time estimates, deals with the problem of uncertain activity times to the determination of estimated time for each project activity. PERT may be termed as the approach of multiple time estimates. It deals with the problem of uncertain activity times by the application of statistical analysis to the determination of estimated time for each activity concerning the project. Under CPM, we use the precise known time that an activity will take, but such a precise known time approach may not be reliable in real-life situations. In order to arrive at a most reliable estimate of time, multiple time estimate approach may be adopted, and PERT performs this task. Under PERT, 3 time estimates are usually employed: the most optimistic time, the most pessimistic time, the most likely time, the optimistic time. It is the shortest time possible. If everything goes perfectly with no complications, the chance of this optimum actually occurring might be 1 in 100. The pessimistic time it is the longest time conceivable, it includes time for unusual delays, and thus the change of its happening might be only 1 in 100, the most likely time. It would be the best estimate of what normally would occur. The difference in these 3 times gives a measure of the relative uncertainty involved in the activity. From these 3 times concerning an activity, the expected time, which is usually adopted under PERT, can be computed by the following formula. The 2 formulae important in this context are standard deviation of the time required to complete an activity, standard deviation of the time required to complete the project, PERT as a control device. PERT is unique in its emphasis on the control phase of project management because it uses statistical analysis along with probability calculations concerning the project completion by a certain time period. As a result, it is easier under PERT to revise the plan each time changes are introduced into the network. Hence, PERT is equally an important controlling device. With the information from PERT, the manager is in a better position to know where trouble may occur, where supervision may be needed, and where resources may be shifted to keep the project schedule. Advantages of PERT. It forces managers to plan because it is impossible to make a time event analysis without planning and seeing how the pieces fit together. It forces planning all down the line because each subordinate manager plans the event. It concentrates attention on critical events that may need correction. It makes possible a kind of feed-forward control. A delay will affect succeeding events unless the manager can somehow make up the time by shortening that of some action in future. It makes possible the pressure for action at the right spot and level in the organization structure at the right time. Limitation of PERT. PERT is not practicable for routine planning of recurring events. Another limitation of PERT has been its emphasis on time only and not on costs. The time estimates to perform activities constitute a major limitation of this technique. The simple PERT technique does not consider the resources required at various stages of the project. Similarities and dissimilarities in PERT and CPM analysis. After discussing and illustrating the PERT and CPM techniques, it seems appropriate to point out the similarities and dissimilarities between these 2 approaches of network analysis. Points of similarities. PERT as well as CPM are used as decision-making aids and performed in some technological sequence. PERT as well as CPM are techniques of network analysis. In both the cases, a project is represented by a diagram or network with each individual activity contributing one element to the diagram. Points of dissimilarities. CPM is used for repetitive jobs, whereas PERT is used for non-repetitive jobs. CPM directly introduces the concept of cost into the analysis, whereas PERT indirectly accounts for cost if we assume that cost is related to time. CPM analysis uses the precise known time and generally considers only 2 time estimates, normal time and crash time, whereas PERT does incorporate statistical analysis and thereby enables the determination of probabilities concerning the time by which each activity as well as the entire project would be completed. Let's discuss about the PERT cost systems. The PERT and CPM network techniques in their original developments were essentially time-oriented techniques. As planning tools, they enabled managers to estimate the time required in the completion of a proposed project. As scheduling techniques, they provided a mean of establishing time schedules for project activities, and as control devices, they could enable managers to check schedule times against actual times for the event occurrences. but gradually it was realized that these network techniques should also be applied into the area of cost control. Since the term PERT cost has acquired a somewhat generic status as description of network cost accounting systems. Basic concepts of PERT cost systems. The basic concept of PERT cost systems is the fact that costs are to be measured and controlled primarily on a project basis rather than according to the functional organization of a firm, such as divisions, department, and so on. PERT cost system mainly consists of planning and control cycles. Planning cycle includes establishing work breakdown structure, defining tasks, preparing an account code structure, constructing network, estimating activity time, scheduling, preparing cost estimates, reviewing and revising the project plan. Control cycle includes approving the project plan and its budget, authorizing the work on the basis of activities or group of activities involved in a project, collecting actual time and cost data, updating the plan, preparing PERT cost reports, analyzing the reports and deciding the course of action. Advantages of PERT cost systems. PERT cost system results in considerable improvements in project cost control since it measures and controls costs in terms of the activities. PERT cost system supplies relatively more and useful information to the manager than possible under conventional cost systems, and this enables him to do a better job of planning and control. But this does not mean that a project-oriented cost accounting system does necessarily replace system based on organization structure. Under PERT cost system, cost overruns are more easily detected and corrective action is taken more readily. In fact, this has been the main argument for introducing a project-oriented cost accounting system. Now we will discuss about the Gantt chart. The basic purpose of a Gantt chart is to break a large project into series of smaller tasks in an organized way. The leftmost column lists each of the tasks in chronological order according to their start time. The remaining columns show the timeline. For each row, a task is listed and a line is drawn through the timeline for the weeks during which that task will be addressed.
In this lesson, I'm going to demonstrate how you transcribe information that you collected or calculated for your network into one of the most famous graphs in project management, the Gantt chart. And here we have a network that we did the forward and backward pass in previous lessons, and we're going to transcribe this information into the Gantt chart. We have the 8 activities listed here, and we have a time frame that spans the duration of the project. And so what we're doing here is we're just identifying which activities are occurring at different time periods along this graph. So we look up here and we see activity A is the first activity. It starts at 0 and has a duration of 2. And so we mark it in. I'm going to mark it sort of squibbly to begin with. It has a duration of 2. Then B can start, which has a duration of 1. And C can start. And notice how the bars are representing the time frame given this timeline. Then D can start as soon as B and C is completed, which is the 5th day. And it takes 1 day, 5 and 5. Then we can start both E and F. E takes 2. F takes 3. And then as soon as E is done, G can start, which is the 8th period. That takes 2 days. And then finally, H can start when both G and F are completed, and that's not until the end of the 10th day. And we go ahead, or the beginning of the 10th day, I should say. and that takes 2 days. So at the end of 12 days, the 8 activities will be completed. And usually what you do when you're done is you try to do a little better job of marking it up so it looks a little prettier than I did. I'm not going to spend too much time on this, but fill it in a little bit. And then the last thing you want to do is identify where the slack is. So for example, B has 1 day of slack, and typically you indicate it like that. Sometimes you can put an X at it if you want to indicate slack. Just be consistent. And we have actually 2 days of slack, so we want to put 2 X's there. And then we also have slack with F. Line up F, and that's over here. And we put in our X there. So here we have a Gantt chart. And the start should correspond with the numbers of the early starts, and then you just mark off the duration for each of the activities, whether it's 1 for D, or in the case of F that starts on the 6th, it's 3 days, and then go back and indicate where the slack is. This is a very famous chart, and every student in project management should be able to do this.
Now in the end, let us summarize what we have learned in this lecture. The two most popular forms of this technique now used in many scheduling situations are the critical path method, popularly known as CPM, and the programmed evaluation and review technique, popularly known as PERT. Network analysis is a technique related to sequencing problems which are concerned with minimizing some measure or performance of the system, such as the total completion time of the project. A network is a series of related activities which result in some product or services, which in turn contributes to the goals of a business or industrial or similar other organization. Critical path method is a graphical technique for planning and scheduling of projects. This technique involves the preparation of the network, is the form of arrow diagram, and its analysis to indicate the wheel path. Resource allocation implies the task of allocation of resources to various activities in such a manner that the allocation is considered as acceptable under the given situation.